Alright, I wouldn't recommend that we glue it in just yet because it'll be hard to write on it if you start to glue it in now. Alright, first let's look at the different types of energies. You have potential energy, and we'll learn about each one of them later. You have your kinetic energy, you have your radiant energy, mechanical energy, and you also have your chemical energy. We'll start with this side. It asks us to define energy. So we'll put the technical one down right now. It's the ability to do work. It cause change. So, define energy, the ability to do work. Cause change. Alright, the ability to do work. Cause change. Alright, so how do you guys think we would illustrate energy? Alright? I probably would use a battery because when you think about energy, most things in order to work, remote controls, wireless cars, different things like that, actually require a battery. So that's my little battery. And we'll put battery on there. It's another illustration of energy that you may have. This is a source of energy. Don't you feel a little bit stronger when you eat food? I'm not a good drawer, so we'll call this food pizza. Give two examples of each form of energy. So we're going to give two forms of chemical energy, radiant energy, and mechanical energy. Well, chemical energy is going to be your stored energy that comes from some sort of chemical reaction. All right? So what type of examples could we use for that? When you think about it, we could actually use a battery again. A battery, because that's stored energy, chemical energy, isn't it? Don't you have a chemical reaction going on when it triggers whatever device it is going to use? And also food, we could use that one again as another source of chemical energy. And the reason food would be a source of chemical energy, because when you eat that pizza, that's actually stored energy. It's going to give you energy. And how do we know a chemical reaction occurs as a cause of it? Well, when you put that food in, it doesn't quite look or smell the same when it comes out. So something had to happen to have a reaction there. So we know some sort of chemical reaction had to occur. So battery and food would be two examples of chemical energy, which is stored energy, energy that is stored, but is going to undergo some type of chemical reaction. Two examples of radiant energy would be, radiant energy is light energy. All right, so we could draw a light bulb for one. And yeah, that is a terrible light bulb, but we're going to call that a light bulb. Another form that gives off light is the sun. So we'll call that radiant energy also. All right, the next thing we're going to look at is your mechanical energy. And that's going to be energy in motion. All right, energy in motion. Kind of like kinetic energy, which is also energy in motion, except this one is leaning more toward a device or something. All right, fan blades turning would be an example of mechanical energy because those fan blades are moving. Turbine gears moving. And those are kind of like fan blades, but we're talking about the gears in the wind turbines. And if you don't know what wind turbines are, they're those big things that kind of look like giant fans that you see out in the country. And the wind blows it, it turns and generates electricity. That's what a wind turbine is. So turbine gears moving. And then running water is another form of mechanical energy because it's in motion, it's moving. All right, and what do you guys think? It says illustrate the primary energy source of Earth. What energy source fuels all the energy on Earth? Think about that. Hopefully as you thought about it, you came up with the sun. All the energy on Earth derives from that sun. That is our primary energy source. Number one energy source. All right, and then we look. Potential energy is energy in a position or stored. Energy in a position or stored. So what that basically means is stored energy. You have the potential to do something. Think of it like the NBA. All right, they draft these players that haven't done anything on the NBA level yet, but they have potential to. All right, so they haven't done anything, but they have the potential to do something. So that's why they're drafting. Well, same thing when you think about potential energy. It hasn't really done anything yet. It's stored energy, waiting to do something. So energy in a position or stored energy. Kinetic energy is going to be your energy in motion. It's actually moving like a roller coaster in motion. Energy in motion. So the kinetic energy is moving. Now, how do you remember the difference? That's a good question. How do you think we remember the difference between these two? Now, the kinetic has to do with movement. When you're talking about something being kinetic, it has to do with movement. So that automatically reminds you that that energy is in motion. And then what did I tell you guys about a basketball player with the NBA draft? Just think about the NBA draft. Those players are drafted based off of their potential, but they haven't done anything yet. They're stored energy. It hasn't been put to motion yet. All right, the next thing it tells us to do is draw the following. Draw an X where the object has the greatest kinetic energy and the least potential energy. The reason they show us that is because they have an inverse relationship. At every location that you have your greatest kinetic, that's always going to be your least potential. And then vice versa. It says draw a Z where the object has the least kinetic. It's moving the slowest and the greatest potential. All right, inverse relationship. Every time you have the greatest for one, you're going to have the least for the other. All right, so we'll put an X where it has the greatest kinetic energy. That means where is this object moving the fastest? That's the greatest kinetic energy. So that would be right here. All right. The higher it is up here, the more potential it has to gain speed. So the lower it is, the less potential it has. So this is going to be your greatest kinetic, the fastest moving. It's also going to be your least potential because it's moving so fast and it's at a lower point. Now the potential to gain much more speed. And it says draw a Z where it has the least kinetic. That means it's moving the slowest. Well, here Z is not moving at all. Or if it is, it's barely moving. So we know that this location up top has to be our least kinetic and our greatest potential. It has the potential to do more because it's up higher here, so it has the potential to go a faster speed by the time it's hit the bottom. So go off of that. Looking at the pendulum, we're going to draw an X where the object has the greatest potential energy. Again, what point is the furthest out, the highest up? All right, if we pull it back to here, it has the potential to gain more speed going across there. If we just pull it back to here, it doesn't have as much potential as it would have had here. All right, and then your kinetic is just going to be before it hits the bottom. So greatest potential is going to be this first location. This is your highest point. So we'll put an X there. And then your greatest kinetic is actually going to be just before it hits the bottom, but we'll go ahead and draw that Z right there at the bottom. Next thing it asks us to do is describe the motion of the darker circle. And to describe that, we would simply say that it starts at the highest potential on the left. If you look here, it starts with the highest potential energy or greatest potential energy, either way you want to say it. The kinetic energy increases as it's coming down, which means it's getting faster. The movement is getting more movement. The kinetic energy, we'll just put KE, increases as it falls. Until it starts to rise. Then the kinetic energy decreases and the potential energy or you could have just put TE, potential energy increases. Because remember, the faster it's going, the more your kinetic energy is increasing, because that's energy in motion. But the slower it's going, the more your potential energy at rest is increasing. So again, it starts with the highest potential energy. The kinetic energy increases as it falls until it starts to rise. The kinetic energy decreases and the potential energy increases. Moving on along, over here we can see the process of photosynthesis happening here, where the plant is intaking the sunlight and carbon dioxide. Alright, in the inside there, it's also taking in water. They're undergoing a chemical reaction process in the inside called photosynthesis, which in turn produces glucose and oxygen. Using the illustration above, identify the following forms of energy. Chemical energy. What is chemical energy? I told you it's a chemical reaction occurring inside of something. So the result of the chemical energy is going to be the glucose, because there's a form of the chemical energy that happened. You had your glucose to form, which is a type of sugar. Your radiant energy, of course, is going to be the sunlight. All right, define your energy transformation. Energy that changes from one form to another. Remember, the law of motion, the law of matter states that matter can't be created or destroyed. It can only be rearranged to form another substance or a new substance. Well, the same thing with energy. It can only be rearranged to form a different type of energy. What energy transformation takes place during photosynthesis? You have your radiant energy turning into your chemical energy. What energy transformation is taking place with the pendulum here? All right, when you go back and look at the pendulum, all right, so we pull it out, we start here, and we have our potential energy, but when we drop it, it's going to what type of energy? Your kinetic energy. So we have potential to kinetic energy.